Okay, my clock shows 2:15, so I'm going to start. Can everyone hear me okay? I'm going to try and speak loud. There's no microphone unless this thing is doing the magic enhancement thing. So this is Git for you and me. If this is not the session that you were looking forward to, it's totally okay to get up and leave. I won't say anything. I want you to have a good experience. So. Thank you for coming. This session and the slides and the speaker notes are already online. You can go to bit.ly/git-drupalcorn. That's bit.ly/git-drupalcorn. And you can even take a sneak peek at my speaker notes. My name is Alina McKenzie. I'm a developer and system administrator based in Chicago. And I've been doing Drupal for about 4 years. I've been active in the community for about 2 of those years. And those 2 last years is when I started to use Git. You can find me online on Drupal.org as AliMac, and that unpronounceable thing right there is my Twitter handle. I have a handy pronunciation guide here. It's Charojeka. So, the plan for today. This is a beginner session. So if you already know Git, how many of you already know Git? How many of you are here just to kind of relax and cool down and just listen to a flow of words? Okay. I knew there was at least a couple of people here. But this is a beginner session. I'm going to introduce some concepts. I'm going to sprinkle them with tips. And then at the end, I'm going to give you a healthy dose of resources for beginners. But don't expect to walk out and simply know everything there is to know about Git. Because I don't even know everything there is to know about Git. I consider myself to be an intermediate person at the end of maybe my beginner stage. So why do we use version control in general? Is it because everybody's doing it and we're just embarrassed and we better do what everybody else is doing it? Well, I thought about this and I came up with 3 reasons why we use version control. One is we want to write our project's history. Our projects are used on servers and computers and machines, but they are written for people. People use them. So we want to write explanation of why we did certain things the way we did, to put our reasoning into documentation. We want to document our projects. The second reason is that we want to undo changes, right? I mean, hitting the back button, Control Z or whatever it is, thanks to that history, we can undo the changes that we make if we need to. And the third reason is that we want to experiment and track changes to our content, to our code, to whatever it is that we're working on. So how do we use version control and Git? In one mode, you can use it as a single user. You don't need to have a server or an account or anything like that. You can simply use it locally on your computer and never ever share with anyone else. And I have a couple of projects that I do exactly that. I just want Git to be my personal backup system, and I don't have those projects anywhere else or shared with anyone else. But as a single user, you can also share those projects, post them on Git hosting systems like GitHub. Another mode is collaborative. When we work in large teams or small teams, we work on things locally and then post our work on a remote server. Finally, what exactly are we working on? What exactly are we talking here? Most people think of code, right? But Git can also be used with other content. You can put your websites into Git, Drupal websites even. You can write books and use Git to track your work as you're writing a book. And finally, you can also use Git to track your slides. The slides for this presentation were done in Reveal.js, and they are in a Git repository, and they're on GitHub. And I used Git to help me write my slides. Okay, the first thing that people tell you about Git is that it's distributed. So I wanted to address this because I think it's true, but there's a little bit of a caveat with that. So let's first look at what distributed and centralized mean. In a centralized version control system, you have a central version control server somewhere, and that server has all of the history of the project. But when you're working on adding new features or fixing some bugs, you are checking out the latest version of the files and not the entire project history. This model is also called the client-server model. And examples of that are CVS and Subversion. Is anyone here familiar with Subversion? Yeah, a couple of people. I also used Subversion before I started using Git. So that's a centralized client-server model. In a distributed model, we have, let me make that slightly bigger. No, that doesn't work. In a distributed model, each developer works directly with their own local repository, and that repository has the entire history of the project. And changes are shared between repositories as a separate step. So, okay, great. Everything's distributed, everything has full history. But then, let's say we all have Drupal in our Git repositories. Which version is like the main version that people are going to be working on? There has to be some kind of agreement on which is the authoritative repository of code or content or whatever. So it's distributed, but there's also usually a central point, central place where people keep the code for a project. So let's talk about hosting for Git. We have a couple of options to host our code externally. GitHub is one of the most popular ones. They offer free public repositories, but you have to pay for private repositories. Now, if you are a student or if you work in higher education or any kind of education, you can get the GitHub Education Student Developer Pack, and that allows you to have up to, I think, a certain number of private repositories. Another hosting provider is Bitbucket, and they offer unlimited private and public repositories, and it's free to use for up to 5 users on your repository. There's also an academic plan. And the last one I have here on this list is GitLab, and they offer free unlimited public and private repositories and unlimited private collaborators. So you can create an account on any of these systems and start using those hosted repositories. If you can't, for whatever reason, use hosted Git repositories, you can also host your own. GitLab CE, which stands for Community Edition, is a standalone Git server that you can run on your own servers, or you can use a hosting provider like DigitalOcean. They have a one-click install of GitLab CE. I do run GitLab CE at my workplace, and I like it a lot. Okay, great. So how do you get Git? There are, you can download it for Windows, I think it comes with OS X, and it might come with certain distributions of Linux. And there are, the most popular way that most people will talk about is that you use Git through the command line. So a little bit of a tip for those of you who prefer to use the command line is updates to the latest version. The latest version of Git right now is 2.5.0, and if you want to get the most recent features, improvements to the help system, you want to run the latest version. But if command line is not your thing, and I totally understand that, there are Git apps that you can use. One of the most popular ones is SourceTree. It is free. It works on OS X and Windows. There's also GitHub for Mac and GitHub for Windows, and it doesn't just work with GitHub. And the last one on the list is cross-platform. It works on OS X, Windows, and Linux. It has a commercial license, but it also has a non-commercial license. So if you have non-commercial uses, you might want to check this one out if cross-platform compatibility is important. And here I have a screenshot of SourceTree, just to let you know that the same concepts I'm going to be talking about and showing you the command line of apply to the graphical user applications as well. So things like adding, removing, branching, merging, all of that applies. You just get nice little buttons and an overview. And that's one of the nice things about the application, is that you get an at-a-glance view of your project, whereas with a command line, you kind of have to do it at command at a time. So no matter how you get your Git, you will have to first configure it. There are 3 different scopes for Git. The first one is system-wide configuration for all users on your system. The second one is global, and that applies to all of just your username. And the last one is local, which applies to directory. So it's a per project configuration. And why that's important will become clear very soon. One of the first things that Git will ask you to do is to configure your name and email address. And this configuration here in this example is global. But let's say that you're working on a project for work. In that case, you might want to change your email address to be your work email address. So in that case, you would do a local configuration of your email address. I have 3 examples of other configurations that I find very useful. The first one is to set your color.ui to true. And that way, you get colors in your output of Git, which is very useful when you're looking at differences between what has changed. The second one here is core.excludes file. Git can be configured to automatically ignore certain files. If you have OS X, you know that Macs will create these .ds store files everywhere, right? And we don't care about those files. We want to globally, we want to Git never even to notice them. And this is something that you can do with a global ignore file. I also use an editor called Vim, and that one produces some other swap files that I want Git to ignore. And so I add those extensions as well. And the last configuration here is to show the trailing white space. So ever since I got involved with the Drupal community, I noticed that not having a trailing white space is really, really important. And so I kind of care about it now, but I didn't before. So now I have Git show me whenever I have a trailing white space, so I catch those errors before someone else points them out. OK, so let's look at a very simple sample project. And I made it so super simple. I didn't want to get bogged down on languages that we know or don't know. So we're going to talk about, we're going to have a local repository and a remote repository. And I'm going to kind of walk you through the process. The project is packing list. We have a directory called, imagine a directory called packing list and one README file inside it. It's readme.md. It has markdown style syntax in it. And the packing list is basically, there's a heading, packing list, and things to bring. So that's the project that we're working with. So what we're going to do next is initialize the repository. And to do that, I'm going to change the directory, go into the packing list folder, and type in git init. And you'll notice in my examples, all the commands that I type in are prefaced with a $. So when I type in git init, Git comes back to me and says, I initialized empty Git repository in this directory. And it's great. So now I have this new folder in there. It's called .git. It's a hidden folder. And this is where your repository Git snapshots and history is stored in that folder. And once you do this, I encourage you to go into that directory and look around, because it's really interesting. Now, if for some reason I decided, OK, you know what, I don't want to deal with this Git stuff. I'm sick of it. I want to remove all kinds of Git stuff from it. All I have to do is delete this directory, and that will delete all of the project's history. And I have done that on occasion when I messed things up real bad, and I just said, OK, screw it, I'm going to start over. So that's how you can do it. So before we get into the details, let's talk about a little bit let's talk about the phases of the project. And when we start off this new project with the README file in there, the file starts off as being untracked. What that means is that Git sees that the file is there, but it doesn't really know about it, doesn't really care about it. It just says, hey, there's a file there, but I don't know what to do with it. The next phase is when we tell Git, okay, you know what, you should care about that file, track it. Now when the file is tracked, Git knows about the file, and it tracks changes to the file. Next, imagine our workspace having all kinds of papers all over the place, and us opening files and editing and moving things around. Well, when we're ready to write history, what we do is we stage files. We put them in a separate sort of cleaner area to prepare them to be written into the project's history. And that's what's called staging, meaning changes are ready to be committed. The next stage after that is actually committing. And you can think of committing as kind of taking those files that are ready, putting them in a box and sealing the box, and then maybe like writing a little note, like, hey, this is that stuff that you wanted. And that's committing. At that point, the changes to the file are saved to the project history. Finally, when we're ready to share all of our wonderful work with the world, the changes are pushed, meaning they're pushed from our local repository up to the server so that everyone else and all the other collaborators can use them. Okay, so now that we know kind of the phases, the direction that the things are going to go, let me tell you a little bit about your 3 sidekicks. Your 3 sidekicks are going to tell you they're going to be useful commands that let you orient yourself in your project. They're going to answer questions like, where am I? And what is going on? And what just happened? Because if you leave your project for a couple of days and you come back to it later, you kind of want to reorient yourself and become familiar with your work again. So the first sidekick is git status. And git status tells us which branch we are on. As you can see here, I just ran the git status command, and it gave me a bunch of information, including the branch. We're on branch master. It tells us that we are on the initial commit, which means that there is no history written yet. It tells us that there's an untracked file, readme.md. And finally, it gives us hints, really helpful hints, like, hey, if you want to track this file, why don't you use git add? This is great. Okay, let's then use git add. So we run git add readme.md, and then we run git status again just to see what happened, right? So now we see we're on the branch master, still in the initial commit, but now the file is staged. It's ready to be committed. And Git tells us, helpfully, how we can unstage it if we don't want to stage it for a commit. So this command git add, it has 2 uses. It starts tracking a file, and it also stages it so that it is ready to be committed. Fantastic. Next, why don't we go and put some things on that list. So here I have the readme.md again, my packing list, and I'm going to add 3 things to it. Laptop, skirt with pockets, and a toothbrush. All very useful things. And now I'm going to run git status again. And it tells me, okay, you're on branch master initial commit, there's some changes ready to be committed. Oh, but there's also changes not staged for commit yet. So Git keeps track of sets of changes within the same file, but treats them separately. Well, if we want to know exactly what has changed since we staged readme.md for commit, we can use our second sidekick, the one that answers the question, what is going on? Git diff shows us the changes between 2 versions of a file. Changes that, by default, the changes that have not been staged yet. So you can see here the output of git diff. There's a bunch of lines at the top, but what we really want to pay attention to is the pluses and minuses, because that tells us the difference. This is what lines were added to the file, and this is what lines were removed. In this case, we don't have any lines that were removed, only lines that were added, the blank line, the laptop, the skirt with pockets, and the toothbrush. Okay, great. Well, let's write some history. Here, we're going to use the command git commit, and we're going to use a shortcut, git commit -m with a message. This is a one-liner to commit everything in one fell swoop. Otherwise, if you run git commit, it opens a text editor where you can write a longer commit message. But this is an initial commit, so we're just going to do a really short message. So git commit -m, and then quotes, and then the message. And that brings us to our last sidekick, which tells us what did just happen. So in here, we have git log, and git log shows you the history of your project. And we just have one commit right now. So you can see there's a commit, there's a long string of numbers and letters after that, and that's the commit hash. It identifies each commit. It's a unique identifier. Below that, we have the author, so my name and my email address that I configured Git with, the date, and the message. Let's look at the commit a little bit closer. So what is a commit? I have this quote by me, actually. A set of related and reversible changes that function together as a unit of work. And the reason why I quote myself is because it is actually up to each of us, each of you and me, to decide what goes into a commit. Git will not tell you that, oh, this is enough or this is not enough for a commit. You have to decide how much work you want to put in a single commit. And a single commit could be just a one-line change. It could be changing thousands of lines. But you kind of want to make sure that the changes are related and that they're reversible sort of in one atomic action. Beware of unrelated changes. If you're adding a title, you should not also be doing something that's completely unrelated to that, or that's outside of the scope. It's usually a good idea to base your commits on tickets, and if you have feature requests and stuff like that. But I know many of you, and myself included, probably like to work and just kind of keep going. When you've got a good streak, when you're working on something and you're like, okay, I'm going to do all these things, and then you stop and you're like, oh, I should be committing things and writing messages and all that good stuff. And then you're like, oh, what do I do now? Well, there's a really handy command for that, and that is git add-p. And this allows you to do interactive staging, which puts you in this kind of interactive conversation mode with Git. Git will ask you which changes you want to stage, and you say, yes, no, not that one. It will only ask you about changes to files that it tracks. So if you have any new files, just remember to start tracking them right away. Don't wait until you fill up a new file and then want to stage just certain parts of that file. You want to use git status to find any new untracked files beforehand. Yes?
Question. If a file has an edit on line 5 and line 105, you do a git add. It's a new file, actually. I'm sorry, new file. Hold on. Git add minus p, are you adding the file to be tracked, or are you committing the file? I'm confused now.
No, this is for staging.
For staging?
Yes.
I use Git a lot, but I'm still at a loss as to where you are in the workflow of Git add minus p. I use git add for adding the new file to the repo.
Right, that's correct, to start tracking them, but you also use git add to stage them.
Some people do, I don't. But you're saying if I build that model, all I do is make an edit, commit it, and go. But I call it my name. So git commit this file minus n.
So you're saying you do like git commit -a, so you don't stage anything?
I don't even syntax at all. I just git commit. You're wrong. Yeah.
All right, let's hash it out afterwards, okay? Because I don't want to keep you all here for too long. Okay. All right, so let's go back to our awesome README file, because there's new stuff that goes into it right now. We had a list, laptop, skirt, toothbrush. And now I'm going to add some headings because I want to sort things by category. So I added these headings: technology, clothes, and toiletries. All right, and now I'm going to demonstrate how git add-p works. So when I do git add-p, it looks a lot like running diff, because it shows me, okay, what has changed. But hopefully you can see that at the very bottom, Git asks you a question. Git asks, stage this hunk, and then it says YNQAD /SE question mark. So this is the interactive mode, and all of these letters stand for words, like Y stands for yes, and N stands for no, and Q stands for quit. And all these other things stand for other things. But what we're interested in here is saying, well, I just want to add a part of this and not all of it. So there's an option here, S, for split. And so we're going to use that, and we're going to say S, split this. So Git says, OK, I split it into 3 hunks, and shows us the first one, just that technology header. And here's where I can say, yes, I want to stage it, and then I can say no to all the other ones. And now, just that particular change is staged for commit. You can also do this backwards. If you staged a file and then you just want to unstage just one little bit, you can use git reset -p to start doing it in the other direction. Personally, I find that git reset -p a little bit confusing, so I would just unreset the whole file, or I would just reset the whole file and then git add p again, because I think that's easier to understand than going backwards. One really useful setting is to set your core.editor configuration. By default, Git will use an editor like Vim, I believe. And that's not the friendliest editor. I think it has a little bit of a learning curve. So if you want to use something like Sublime Text or Atom or some other editor, you can tell Git to use that editor for commit messages. Now let's take a look at a longer commit message, because before we just kind of used a one-liner. The way you structure your commit messages is totally up to you, but there are some best practices that people have adopted. One such best practice is to use a kind of a short subject line and then do a new line, so blank space or blank line, and then a paragraph of describing what the change is about. And the sort of format that people use for the subject line is, imagine saying that, starting to say, this commit will, and then you go and write your message. So this commit will add a short descriptive subject line. And if you have a ticket number, you would probably include that in the paragraph, or maybe prefix the subject line with the ticket number. Whatever it is you do, be consistent. You're going to thank yourself later for being consistent. OK, so we did this. We committed things. We have a history now. It's time to push the changes up to a remote repository. So I went and created an account on Bitbucket and created a project called Packing List. And now what I want to do is tell my local Git installation that there is a remote account to which I can push code. And so I do this by using the command git add remote, and then origin, and then a long address of that repository. This thing origin, it's a name. It's a convention. You can use any meaningful name for this. Like I could have said git add remote Bitbucket, and then the address of my Bitbucket repo. So whenever you see origin, just know that it's a convention to name your remote repository that. Finally, I'm ready to push the code. So I use git push -u, origin master. Origin is that repository name, and master is my master branch, which I'm pushing to the remote repository. OK, but let's talk about fun things like undoing things. There are many ways to undo in Git, and it usually depends on the phase that you are in. So if we think back to those phases that we had untracked, tracked, and then staged. So if we're in a phase that we have not committed yet, we have not written history, we can, if we have a file that's staged, we can unstage it with command git reset. So git reset head readme.md will unstage that file. Or you can use git reset -p, which will do it piecemeal. You can also undo all changes to a file by doing git checkout, and that will basically get the most recent version of the file that had been written to the history of the project. OK, but let's say that you've committed, you've made a commit, you've written to history, but not yet pushed. Well, you can easily update last commit, the very last commit that you have, with the command git commit -- amend. And to do that, let's say, so you just committed and you're like, oh, dang it, I was supposed to include this one image with this slide. All you have to do is add it, do a git add to stage it, and then git commit -- amend will treat it like as if you're still writing that the very last commit. If you want to just completely undo the last commit, you can do that with git reset -- solved head ~1. That moves it back one commit. You can also do it for more than one commit. So if you want to go just completely blow away the last 3 commits that you've made, 3 times that you've written to your history, you can do that. And if you want to undo a specific commit somewhere way back in the project, you simply say git revert, and then you provide the first 7 or 8 or the whole number, the whole commit hash. And that will create a new commit that will say, this is reverting the previous change, the previously committed changes. OK, what if you've pushed to the remote repository already? The advice everywhere is that you don't undo that, OK? Because when you've pushed, that means that there might be other collaborators on your project that might be using that code already and have that history written. And if you're messing with that history, you're messing with them. Now, if you are the only contributor, like I am, for example, to this repository, you can use the -f flag to force push change that includes messing with history. But I try not to do that because that's kind of like a best practice and a good habit to get into. Simply, once you've pushed, you wouldn't mess with the history. You can do a revert and then revert specific commits, but don't rewrite history. OK, so this was a lot of stuff. There is a really handy flowchart that was designed by Emma Jane, who's a Drupaler, and it's called Undoing Changes in Git. And it's a flowchart that's too big to fit on my slide, but I have a link to it. So if you're ever in a bind and you're like, OK, how do I undo this? You can use that flowchart. It's kind of like a decision tree. It's really great. I highly recommend it. OK, I'm going to cover the more kind of advanced topics of Git right now. So if you at any point feel like, oh, this is too much, or I'm not doing a great job explaining this, or something like that, don't worry. What I'm trying to do is just expose you to the concept. And at the end, I'm going to give you some resources to follow up on. Branching. Branching is a very, very nice feature of Git. It's one of my favorites. It's basically a cheap way to create copies of the project without actually copying it. So without Git, if you wanted to kind of mess with your code and take it in a new direction, what you would do is probably copy the directory and then do stuff with it. And then, if you wanted to do maybe a new direction, you would copy it again. But it makes it kind of hard to integrate the changes between the different directories. Well, branching is kind of like making copies, but it's a lot smarter. And it's easy to integrate changes between one branch and another branch. So let's look at branching. This is a diagram of a Git project, and the circles with numbers represent commits. So we have commit number 1. That's one thing written to history, one set of changes. Then we go and we do another set of changes and commit it and write it. And we do another set of changes, the third commit. And we have a pointer that points to it, which is master, which is the branch that we are on. And then we have another pointer that points to that pointer called head, meaning like we are on that branch right now. This is what we're doing. We're dealing with the master branch. OK, so this is our starting point. And now we're going to create a new branch. So we do that with the command git branch test. What that does is simply creates another pointer. It points to the same commit, the third commit. Great, fantastic. But we are still on the master branch because head is still pointing to the master. So to switch between branches, we use the command checkout. Git checkout test will put us on the test branch. Okay, but nothing exciting has happened yet, right? We're on a new branch, but we haven't done anything. The exciting stuff happens when you actually make some changes and make commits. Here's what happens. The master branch stayed way back in the third commit, and now our test branch has a new commit on it. It has new experiment that we were doing. We changed all the links to be, yellow or something horrible like that. Okay, well, we don't like that the links are yellow, so we switch back to master branch. And now head points back to master, and we're done. We can delete that other branch if we don't like it, or we can do some other things. But our directory remains the way it was before we started the branch. Branches are typically created for new features, hot fixes, and some projects, like Drupal, use branches for each major version. So there's a branch for Drupal 8, there's a branch for Drupal 7, and those branches kind of just live there forever. Okay, that's fantastic. So we can do, unlimited number of branches here. But how do we integrate the changes? And there are two ways to integrate changes. The first one is merging. Git merge is one way we can integrate changes from one branch to another. When we do a merge, a couple things could happen. The first thing, the nicest and simplest thing that could happen is a fast-forward merge. A fast-forward merge looks kind of like this. So let's review. After git checkout master, the head is pointing back to master, and we have a test branch that is ahead of us at commit number 4. Okay, now what we do with git merge test is that since there are no new commits on the master branch, we can simply fast forward and advance master to be the same as the test. Okay, that was really simple, but things are rarely that simple in life. Most of the time, things look like this. You have your master branch, you have your test branch, but each of them they're going in different directions. There's a new commit on test branch, and there's a new commit on the master branch. Okay, what do we do now? Well, if you run git merge test, it will do something like this. It will create a new commit, and that's called a merge commit. And that commit kind of ties the knot between the two branches. And now master and head are pointing to that latest commit. Another way to integrate changes is to rebase. So let's look again where we were, where we have two commits that are new. One is on the master branch and one is on the test branch. They're different, and we want to bring them together in line. We like our test changes. So we do a git rebase. And the first step of the rebase looks kind of like this. What we do is we look at our test branch, and we kind of lift all that work that we've done on the test branch and put it to the side. So this is why commit number 5 is in this box. It's to the side. And we advance the test branch to be the same as the master branch. So they're the same now. That's step 1. After this, we're still holding on to that commit number 5 and all that work that we've done. Step 2 of a rebase. In step 2, we apply all those commits from the test branch that were lifted on top of where we were after the advance. So now, as you can see, we have our master is at, And so the test branch has the commits from master and also has the commit from the work that was done in the test branch itself. And now it's easy for us to merge the two branches together because we can do the fast-forward merge, the simple merge that I talked about before. We can just advance master to that number 5 commit. This is very useful when you need to keep a separate branch. For example, when you publish things on GitHub Pages, there's a separate branch that you need to keep. It's called GH Pages, and all you do for that branch is just keep rebasing it on master, keep rebasing it, and just have it be in tune with the master branch. Now you'll notice that there is an asterisk after the number 5. And that is because even though the change, the set of changes is the same, the commit history changes, the commit hash changes. So git rebase rewrites the history a little bit. So you have to be careful and not rebase and then things that have been already pushed. Okay, so far, so good. We've had, everything kind of went smooth. But what if there are conflicts? Conflicts occur when same lines are modified in different ways. So if you think back to the readme.md file, and there was a line there, there was a sentence, things to bring. Now imagine if that line were modified in 2 different ways by 2 different contributors. Let's say contributor 1 changed the line to things to bring on a trip, and then the contributor 2 came along and said, no, it should be things to bring on an expedition. So both contributors modify the same line to add different words, but when the second person tries to merge or rebase, Git will tell them that there's a conflict. In a conflict, Git will stop the activity, whatever it is, merge or rebase, and it will list the files with conflicts. And then it's up to you. You have to resolve the conflicts, and you have to stage the files that were affected to mark them as resolved. So here's what that might look like. In an example of our file, the conflict markers look like this. There's 7 less than signs, and then it gives you the name of the branch. And it says, this is one version that this file was modified. Then there's 7 equal signs, and then there's the other version, and another conflict marker with 7 greater than signs. So the way to fix it is you basically have to replace the text between the markers with whatever it is that your resolution is, and then delete the markers. And a resolved file will look like this. We decided that that was the correct way, or the way to say that line. And to finish resolving the conflict, you would do git add readme.md to stage the file and mark it as resolved. Okay, I know that was like a whirlwind tour. So I want to leave you with some good, solid places to look at on your own. And the first one, before I start, I want to say this. Do not be afraid to take the next step with Git. Just experiment with Git commands. Delete the directory if you need to. There is usually more than one way to do a thing. And whatever it is that you decide to do, write down your conventions. Writing things down is really helpful, and you will thank yourself later. So the first place that I think you should look at is Git immersion. And again, this is all in my slides, so Git immersion is a guided tour that walks you through the fundamentals of Git. It was inspired by a premise that to know a thing is to do it. It is a step-by-step kind of tutorial, so it's good for people who like to learn step-by-step. A similar resource is Try Git. It was created by Code School, sponsored by GitHub. It is an in-browser tutorial, so you don't even have to install Git to try it. This is for people who want that instant gratification and just want to start writing commands in their browser. This third resource is Visualizing Git Concepts with D3. I really like this one. This one, the D3.js library, it's a JavaScript library for data visualization. And it animates Git concepts like branching and pushing and merging much, much better than my crappy diagrams. This is for visual learners of Git concepts, because you get to see those commits and you get to see what is happening. This Git for Teams is a book, and it's not finished yet. I think you can get the ebook, and it's like in the process of being written right now, but you can already read some of it. It's a very nice, comprehensive look at using Git for teams of people. And if you're looking at, okay, what strategies do we use? What workflows do we use with Git? this is the book that you want. It's for people who are looking to integrate Git into existing teams and want to settle down on some conventions and strategies. Finally, this book is an in-depth look at Git and what's inside Git. It's called Pro Git, and this is for people who like to take things apart to learn. It has a chapter on like the plumbing of Git and how Git does its things. It's wonderful, and it takes a really good, solid look at Git. Finally, I want to thank you all for being a great audience and putting up with me for an hour or 45 minutes or whatever it is. You can look at the repository of where my slides are at github.com/allymac, Git for you and me. Thank you.
I was totally wrong. Doug is right.
Yeah.
I didn't know you could do that either. I thought you could do -A.
I swear I was taught that. I didn't make it up.
If it works, it works, right?
Yeah. Oh, yeah, that was great. I learned some things.
What did you learn? Tell me what you learned.
So, the thing about the head being a pointer to the branch, which is a pointer to the commit, really made sense for me. So, that's like much more super clear in my brain now. Because I'm into pointers.
You know, that is such an honor for me to hear that from you because you taught me about pointers and linked lists like
I know,
years
I'm
ago.
thinking directly into my brain. Yeah, that was great.
I was excited to learn about -P too. I didn't know that. Like
That is my favorite thing. I never use git add unless I'm actually starting to track a file. But if I'm not, if I'm doing something, because Git just gives you the changes. So you don't have to look at, oh, what's changed.
Yeah,
Just give it to me on a silver platter.
like I just had to do that earlier this week with some new changes. Like I changed a whole bunch of things, and they're really separate issues. It's like, so I like copied the file with my changes, and then I reset everything, and then I like copied them back into pieces, and it was painful.
Oh, you're going to love that.
Yeah.
P seems pretty cool.
Oh, you should promote the practice in
The what?
at the spring.
On Sunday?
Yes. Are you looking
Oh, you want me to tell everyone to come to the sprint on Sunday to practice your Git skills?
I'll also comment that the source tree is truly awesome, and if the command line scares anybody, source tree is really an effective tool. In fact, I keep it around for teaching for people, but every now and again I'll pop it open and just get a graphical look at the branches and branches and whatnot. It's very versatile.
Yeah, I was thinking about trying to do the next workshop with just with just graphical graphical user interface applications for Git and not do any commands.
Yeah.
And that would be interesting to try that. Teach Git through the GUI.